Hi Level 2s and welcome back to 2.5 Organic Chemistry Lesson 1 Part B. So we've just been talking about how we name, and so we're just going to do a few more examples together and then you're going to have some time to do some stuff on your own. So if we look at the structure, remember we've got to identify the longest parent chain. So if we start here, 1, 2, 3, 4 across the bottom, or 1, 2, 3, 4, or 1, 2, 3, 4 reading around the corner, or 1, 2, 3, 4, 5 reading around the corner. So 5 is the longest parent chain, so that means that the end of the name is going to be pentane. So now we need to assign where the branch is. So if we have 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, the branch actually always has to be the methyl on carbon number 3, whichever way that you make that, whichever way you start your pentane. So therefore this name is going to be 3-methyl pentane. So what if there are two branch chains, which sometimes happens? If they are identical, then we name them like dimethyl or diethyl. Or if there are three, it's trimethyl or so forth. So that doesn't make much sense until we see an example. So here's an example here, where if we find the longest parent chain, so 1, 2, 3, 4, or 1, 2, 3, 4, or 1, 2, 3, it's not going to be that, 1, 2, 3, it's not going to be that, 1, 2, 3, 4. So whichever way we do it, there's always two branches on carbon, this carbon here, and this carbon, if we number from this side, 1, 2, 3, 4, or if we number from this side, 1, 2, 3, 4, 2 gives the lowest possible number. So that means that it's going to be 4 is the parent, which is butane, and then we've got two identical branches on carbon number 2, and so therefore this is going to be, now this is where it gets a little bit tricky. You have to do 2, 2 to show that there are two groups on carbon 2. So 2, 2 dash, because numbers don't like to touch letters, dimethyl butane. So I'll say that again. So we've worked out that the longest chain was 4 carbons, which stands for butane, and we can see that there are two identical branches of methyl on carbon 2. So we say 2, 2 to show that there are two groups, and dimethyl to say that they're the same. Be mindful, a comma always goes between numbers, and a dash always goes between numbers and words. And that's what I've just said to you there. So 2, 2 dimethyl butane. Okay, so let's now try and draw one. Okay, so if we try and draw 2, 3 dimethyl butane, I'll show you how it works. So we first of all draw the butane, 2, 3, 4 carbons. And it says on carbon 2 and 3, there are methyls. Carbon 2, carbon 3, there are methyls. Now I'm going to put hydrogens. Can't ever forget the hydrogens. And this is how we draw that structure. Okay, 4 carbons equals butane. Okay, 2, 3, meaning on carbon 2 and 3, there will be methyl groups. I hope that makes sense. So 2-methyl pentane, what's wrong with this picture? Well, it's not necessarily massively wrong, it's just a technicality. This here is mixing condensed structure with expanded, and it shouldn't happen. But you'll see loads of pictures like this on the internet, and so it's kind of like an ignored fact. And if you did it in your exam, they wouldn't actually mark you down. But just technically, that shouldn't happen. Let's go through and name this just because we're here. So we find the longest parent chain. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So pentane's the longest. Even if we read around corners, 1, 2, 3, 4, 5, it's still 5. So pentane, and we need to give the branch the lowest possible number. So it's going to be starting from the left. So it's going to be 2-methyl pentane. This all just takes a lot of practice. Let's now name this one. So it's quite easy to see that the longest chain, what the longest chain is. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and it's on 5, so it doesn't matter if I start the other way. So 10 is decane. Okay, and the branch is on carbon number 5. So this is 5-methyl decane. Okay, what if we've got different branches, so multiple branches? So in this example here, let's find the longest parent chain. So 1, 2, 3, 4, 5. Okay, or 1, 2, 3, 4, 5. Okay, or 1, 2, 3, 4. So it's going to be one of the 5s, either straight across or around the corner, but it wouldn't matter if we did straight across all around the corner because the branches would all be on the same carbon. So therefore I think it's easier to make this one the parent chain because it's the same, and do the 2 branches off the same carbon here in the middle. So you'll see that there are 2 branches, but they're different. So the parent chain is 5 carbons, which is pentane. And what you'll see is you've got a methyl group here on carbon number 3. Doesn't matter which way we order it. 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. We've got methyl and ethyl here. So therefore, what do we name first? We go alphabetically. So E is before M in the alphabet. So it's going to be 3-ethyl, okay, and then -3-methyl pentane. Remembering letters don't like touching numbers, so there's always a dash. So ethyl before methyl, because alphabetically E is before M. Ethyl before methyl. So let's give this one a go. Let's find the parent chain. So 1, 2, 3, 4, 5 across the middle, okay, or 1, 2, 3, 4, 5, okay, or 1, 2, 3, 4, 5. I can only get 5 no matter what I do. Okay, so 5 is the parent chain. So now we need to find what gives the lowest possible numbers for the branches. So if this is carbon 1, 2, 3, 4, 5, you have an ethyl on branch 3 and a methyl on branch 4. So let's look somewhere else and just see if we can get, because we want the lowest possible numbers. So 1, 2, 3, 4, 5. So if that's the case, and that means that you've got a branch on a methyl branch on carbon 2 and an ethyl branch on carbon 3. So that's definitely preferred so far. So that was numbering from the left. So let's number up here. So 1, 2, 3, 4, 5, and it makes no difference. That's going to be the same, except this number is going to be bigger because that one would be, because that was 1, 2, 3, 4, 5. So that would mean that you had your, what have I done that side? 1, 2, 3, 4, 5. Yeah, so these ones would have higher numbers because this one would be attached to carbon 2 and make, oh no, hold on, 1, 2, 3, 4, 5. Yeah, and make it more difficult. So I think the easiest way to name this one here is going to be to go around the second way that we went. Sorry, 1, 2, 3, 4, 5, which means that you've got your methyl group on carbon 2 and you've got your ethyl group on carbon 3. So I would say, and we name the ethyl first, so it's going to be 3-ethyl, 3-ethyl, okay, dash, okay, 2-methyl, and then pentane. Okay, so you've just got to find the lowest possible numbers, and sometimes you have to look at it a few times to make sure that you don't make any mistakes, and you will get better at it and you will get quicker at it. It's a bit hard with me scribbling all over here, sorry team, it's hard to make these neat. So what if the branch can only go in one position? If the branch can only go in one position, then the number is redundant, and what we mean by that is it doesn't matter if we'd put the branch on this carbon or this carbon, it'll always have to be 2-methylbutane, because you can't put a branch on this end carbon, and I'll show you what I mean. You can't have 4 carbons and then put a branch on the end, because then that actually makes it 5 carbons because it reads around corners. So if you've got a butane molecule, the branch has to go on one of the 2 middle carbons, which is carbon 2 or 3. And so it doesn't matter, because if you read from this, because it reads forwards and backwards, if it was on this carbon, it would be 2-methylbutane. Or if you read from this side and put it on this carbon, it would be 2-methylbutane. So you don't actually need sometimes to put the number, but I think it's good practice, and so I tell kids to do it every time. So just a wee test to check how we're going, I'm going to get you guys to name these structures just to see that we're going okay. So we find the longest parent chain, which is this top one here. There are 3 carbons, you can see that nice and clearly. There's a branch on carbon 2, so it's going to be 2-methyl and then propane. Let's do this next one here. It reads around corners, don't forget that. So 1, 2, 3, 4, or 1, 2, 3 across the top. So 4 is going to be longer. Okay, so this is going to be the parent chain and this is going to be the branch. To give the branch the lowest number, it'll have to be 1, 2 instead of the other way would make it 3. So 2-methyl butane. Again, lots of practice with this. Okay, team, so we've got to find the longest chain here. So 1, 2, 3, 4, 5, 6, 7. So that's quite easy. 1, 2, 3, 4, 5, 6, 7. And if we did it this way, it would only be 1, 2, 3, 4, 5, 6. So 7's the longest, which is heptane. So then we've got to name the branch. Now the branch is going to be ethyl, and we've just got to give it the lowest possible number. Doesn't matter which way we read it, it has to be on carbon 4. So it's going to be 4-ethyl heptane. The final one here, let's find the longest parent chain. 1, 2, 3, 4, 5, 6, 7, which is heptane again. Okay, and it doesn't, this one here, we've got to work out what's the lowest possible numbers. So you've got 2 branches here, an ethyl and a methyl. And so if we name from this side, 1, 2, 3, 4, 5, 6, 7, or if we number from this side, 1, 2, 3, 4. So it's either 4 or 5 or 3 and 4. 3 and 4 are smaller. So it's going to be, this one here is going to be 3-ethyl, 4-methyl heptane. Okay, and continuing on, the last final thing to mention is that you can actually have these things known as cycloalkanes, where instead of them being just one straight chain, they actually form a ring, and all you do is join the carbons together and you name according to how many carbons. So if there are 3 carbons, instead of just normal propane, it's called cyclopropane. This one here are 4 carbons, so instead of just butane, it's cyclobutane, and so forth. The one difference here between a cyclic structure and a normal alkane is the fact that there has to be less hydrogens because you don't have a CH3 on either end. There's just CH2s in the molecule, so it has less hydrogens by 2. That's the only difference. We don't really cover cycloalkanes at all in level 2. It's just something that I think that you should appreciate and know about. And there you can see some more cyclohexane, cyclopentane. Okay team, here are the tasks that you're going to be doing. So you have to do naming alkanes worksheet 1, which we're going to do in class. SciPad pages are going to be for homework. They'll take you about 20 minutes. And this one here is optional if you're feeling like you're struggling. All right team, I will see you tomorrow for lesson 2.